Hello everybody. Today we are going to discuss the continuity of a function. So if you have a piecewise function f of x, so this function is continuous at a point x equals a if and only if f of a is defined, limit f of x when x tends to a from the negative side equals limit f of x when x tends to a from the positive side. Number 3, the answers in number 1 and 2, f of a and limit f of x when x tends to in general to a are equal, so this function is continuous. For example, x squared here is continuous, but 1 over x is discontinuous because you cannot use 0 here in the denominator. For example, if you have f of x, which is a piecewise function, and we want to discuss the continuity of f of x at x equals 0 and x equals 2, so you have to check that this function satisfies the 3 conditions. Let me start with x equals 0, so you have to check that number 1, f of 0 is defined. To find f of 0, you have to use this rule because here you can use x squared when x equals 0, so f of 0 equals 0. Limit f of x when x tends to 0 from the positive side, you have to use this rule because here x bigger than 0. So use x squared, substitute x equals 0 here, so the final answer is 0. Limit f of x when x tends to 0 from the negative side, so you have to use this rule here at x smaller than 0, so substitute x equals 0 and the answer is 0. The two limits, the right limit and left limit, are equal, so condition number 2 has been satisfied. Condition number 3, you have to check that in condition number 3, you have to check that the answers here, f of 0 and limit f of x when x tends to 0 are equal, so condition number 3 has been satisfied. So f of x is continuous at x equals 0. For x equals 2, here x equals 2, there is no equal here, so 2, x equals 2 doesn't belong to the domain of this function. So f of 2 is not defined. So condition number 1 is missed. So f of x is discontinuous at x equals 2. Here we have another example. F of x here is a piecewise function and it is continuous. We know that this function is continuous and we have to find it continuous at x equals negative 2 and x equals 3. You have to find the values of the unknowns a and b. Since this function is continuous at x equals negative 2, so the right limit and left limit are equal. Limit f of x when x tends to negative 2 from the positive side equals the limit f of x when x tends to negative 2 from the negative side. So limit ax when x tends to negative 2 equals limit x squared minus b when x tends to negative 2. When you substitute here x equals 2, so we have negative 2 squared instead of x, negative 2, because x tends to negative 2, minus b equals, substitute x here, negative 2, so you have negative 2a. Finally, we have b equals 4 plus 2a, or you can write a equal b minus 4 over 2. Since this function is continuous at x equals 3, so the right limit equal to the left limit. When x tends to 3 from the positive side and x tends to 3 from the negative side, so you have to write limit x squared minus b equals limit x plus 1 when x tends to 3. So you substitute here x equals 3 plus 1 equals 3 squared minus b. So solve this simple equation, you can find b equals 5. Back to the first one, a equals b minus 4 over 2, so a equals half.